Hi, everyone. So I'm from ThoughtWorks. ThoughtWorks is a software consultancy. And what we do a lot of is helping clients, and have done a lot of over the past sort of 5 or 6 years, is helping clients adopt continuous delivery. So what I'm going to do is tell you some funny horror stories of helping clients do that, and what are the realities of actually adopting these kind of practices in the enterprise. So I'm not going to explain what continuous delivery is, because a lot of people have done that before me. Some of my colleagues a couple of years ago wrote a book about it. But what might surprise you to hear is, even though we'd been doing continuous delivery before the book, which was written in 2010, I actually said to a client one day, you can't have continuous delivery. So let me tell you a story about how I got to this place, this sad, sorry state of affairs. And all good stories start with once upon a time. So once upon a time, I was a software developer in .NET for like over 10 years. I did a lot of continuous delivery stuff, and I thought I knew what continuous delivery was. I read the book. I kind of felt like it was my duty as a thought worker. I was doing it on my projects, and I was regularly releasing to production-like environments and automating build and deployment pipelines. But then one day, a client, a big, large enterprise financial client, asked for continuous delivery because they'd read the book and they heard the benefits, and they were really struggling. They were on a very slow release cycle of every 6 months, and then a monthly hotfix. So they were on a recycle of every month. And by the time we rocked up, it was the third weekend of trying to get the hotfix out. And the hotfix required basically everyone, every skill, ops, dev, testing, the whole lot, to turn up into the office of the weekend. So by the time I got there, they weren't very happy. So they said, can we have continuous delivery, please? And I said, sure, why not? But 3 months later, everyone was like, are we there yet? We spent a lot of money on this. Do we have continuous delivery yet? Actually, a client executive shouted at me and said, where is my continuous delivery? He didn't have it. So how did we fail so miserably to not even implement some of the most basic stuff of continuous delivery? Well, they say you learn a lot from your failures, so I'm going to share what those were with you now. Because this was their biggest problem. Their code base was huge, complex. 70 million lines of code with millions of dependencies. Their architecture was, to be frank, a complete mess. And Jez Humble, who wrote the continuous delivery book and came down, didn't tell me about this. He didn't write this in the book. So we've all learned a lot in the post-continuous delivery world, and in particular that operationalizing software is actually very hard. And also learned that continuous delivery is quite big, because lots of people think it's just environments and deployment and build pipelines, but it's also data management and configuration management and continuous integration and quality assurance and architecture. Ooh, and don't forget about release management. And don't forget that you also might need to change your organization. So it's pretty big. And in most organizations in the enterprise, each one of these boxes is a different organization that are incentivized differently and measured differently. Sound familiar to anyone? Yeah, that's good. So I'm just going to talk about this bit right at the start that makes it really, really hard. So this is the new world that everyone's after, right? There's all these cross-functional teams using platforms, self-service platforms to deploy value to customers. So the old world of broken down silos is supposed to become cross-functional teams, just like magic. And this slow infrastructure that you have to submit tickets to get hold of is supposed to just become low friction and self-service. This is what clients keep asking us for. They're no longer asking for continuous delivery. They've also kind of stopped asking for microservices. Now they want containers, and they want self-service platforms, and they want PaaSes, and they want everything. They want to run before they can walk. Because CD was always about building stuff right and being able to deliver stuff rapidly that wasn't broken and didn't make operations people hate you, because they did hate us. And in fact, you work with them and you become partners and you call yourself DevOps. So what's in the way? In order to create platforms to deliver, you need not just technology, but also the right people and the right processes. So the things that are in your way are legacy technology, legacy processes, legacy people. No, not legacy people. Legacy organizational structures and management. I'm joking. Replace the people. No, jokes. So let's start with the easy one. Legacy technology. I didn't think I was going to say that was the easy one, but it is the easy one. And this one isn't easy. Anyone know what this is? You can shout if you want. Dependencies. It's the giant ball of mud, the most common software architecture pattern there is in the world. It's also the business systems of one of the largest financial organizations in the world. And in enterprises, you're likely to have hundreds of these. But even at startups, because I've also worked at startups, you have these too. Because at a startup, why would you build the perfect architecture of something when you don't even know if you're going to use it? It seems like a lot of waste of time, even though as developers we are in the habit of sometimes over-architecting things and trying to create something perfect. But you don't know it's perfect if nobody's using it. So imagine the value that you want to deliver to your customers or that your organization wants to deliver to its customers is right here. This has two key problems. Just two, it has loads actually, but I'm just going to call out two. It's extremely hard to maneuver. It's slow and expensive to get business functionality out, and one change can have far-reaching impact. And it's very inflexible. But also, what's also very important about this is it's really painful and demoralizing for people to work in this. You also can't get the benefits of things like scaling and multi-tenancy when you've got this thing. I mean, what are you going to do? Just dump it on like loads and loads of servers and horizontally scale it all over the place? That's not quite what you're after. So the paper that Brian Foote and Joseph Yoder wrote, summarized in these 3 words, is that technical debt like this is caused by expediency over design. So we're busy getting features out the door and not thinking about the design. Or at least you would think it was that simple, but it's actually a little bit more complex than that. Because technical debt can be caused by many things. First of all, it could be like, we have to meet these certain compliance requirements. We have to ship now and just deal with the debt later. But you have to remember, this is debt. You have to pay it off at some point, and that's the part that people can kind of forget about in the metaphor. Your debt can be completely inadvertent, so you might have teams or developers or people that don't really understand the way that the system is supposed to be designed, the way that you've architected the system. Layering is a very simple example, but I can give you one that just happened to some developers on our teams just last year when we decided to implement a very large-scale event-driven architecture. That was quite a paradigm shift for the developers to go from their old way of developing software to a new way, and so they made mistakes sometimes and broke the paradigm down. So technical debt can be prudent or it can be reckless. It can also be deliberate or inadvertent. So if it's reckless and deliberate, and you decided to go down the agile path and throw out all the documentation, you say, we don't have time to design, we're going to do it later, we're going to do it together when we're developing it, or not at all. So when is a good time to design? It's the question we always get asked. Because obviously, over time, if you don't properly architect and design your software fit for purpose, eventually it gets harder and harder to add the features that you want. And the idea is that if you do nice, good design, then it's going to be easier to add features over time. But people always say, like, but when is the good time to do good design? We should probably be thinking about it all the time. But this is the biggest it depends question in software consulting. I don't know when is the right time for you to change the design of your software. It takes experience. It takes experience of going through lots and lots of different kinds of pain. But there is another kind of technical debt that gets created even when you're being prudent, and it's still inadvertent. Because now that we're doing things like continuous delivery and we're deploying software into production on a regular basis, we start to see how users are really using the software. And now we know how we should have designed it. You see, this is really tricky for engineers to talk about because telling like business people, like, sorry, we did it wrong, not because we were rushed, not because the team needed upskilling, and not because we didn't have time, because we did it wrong and we didn't know how the users were going to use it. So what do? Well, the good news is now you have an opportunity to do something about it because every business is claiming that they're a technical business. And they no longer consider us to be a cost center. Woo, we finally won. But they want to leverage the benefits of scaling and the efficiency of cloud. They want self-service platforms. They want to be able to deliver value faster to their customers. So this is an opportunity for us to tackle all this technical debt and get real about what that involves. But that technical debt actually comes down to two fundamental issues in software, engineering and design, that we just keep making the same mistake over and over and over again. Coupling and cohesion. For those that know what the technology radar is that ThoughtWorks produces, when we put that radar together, we often have heated debates about many things, as you can imagine. And we recently had a debate about coupling, and literally half the room was like, coupling is bad. And the other half of the room was like, well, it's a little bit more complicated than that. The thing is, it's not actually good or bad. It always depends. It's a trade-off. You have to think about the life cycle of how the technology is going to be used. Now, to give you an example of bad coupling or coupling done wrong, I'll talk about an airline that was grounded for, instead of just a few hours because of an issue, was grounded for 24 hours because of the IT systems. Because what they'd done is they'd coupled their reservation with their boarding system in the database, because database integration was all the rage at one point. But they have a very different life cycle. So when people were at the airport trying to board the plane, people at home were kind of like, should I set off for the airport now? So they're like hammering the website, just keep refreshing, and eventually brought the database down, which brought the boarding system down, which meant that nobody could board the plane. So then this problem propagated. That's bad coupling, because that is actually bad coupling. Because when it comes to software architecture, it's really just the tension between coupling and cohesion and thinking about what's the life cycle of the functionality that you're trying to build, and also what's the deployment life cycle of that functionality, and then getting your heads together and thinking about where should you couple and where should you not, because you always have to couple at some point, because most systems are bigger than just one tiny little service. Most functionality is bigger than just one tiny little service. And the answer isn't microservices, by the way, because this is our latest silver bullet. That was some British sarcasm there. Microservices are not the answer. They are a post-continuous delivery architectural pattern based on a lot of things that we've learned around being able to automate and deploy infrastructure and all the things that we learned that didn't go quite so well in the SOA world. But the point is, it's something that we started using quite heavily at ThoughtWorks because it allowed us to deploy things independently and treat things as their own mini applications. And then we had containers and everything was awesome. But they don't solve the coupling and cohesion problem. In fact, they just make it worse. Because in a microservices architecture, you've actually moved the coupling from like in process to external and distributed, which has a whole host of other problems associated with it, which I won't even go into, because this is not a talk on distributed architectures. The point is what what microservices actually provides is it forces you to think about coupling. And that's actually one of the things that I think the real benefit that it brings. Because people have to start thinking about, well, if I couple this to this service, then how do I deploy? And if I couple this to this service, will this break or will this break? But you're adding all this extra complexity around testing and eventual consistency and event-driven architectures and whatever else that you may come up with in order to figure out how to implement microservices. But the point is, in the microservices world, if you get the coupling bit wrong, it's a nightmare. Because the coupling issues become integration issues. And integration has never been something we're very good at either. We've still got a lot of lessons to learn there. So they don't solve the problem for you. They simply force you to be thinking about it because you have to be constantly vigilant against services that talk too much. You also now have to think about messaging and integration and communication and maybe domain design and maybe eventual consistency and a billion other things. So it's kind of a trade-off. But if you want the independent scaling benefits and the independent deployment benefits of microservices, then this may be a route that you want to go down. And there are patterns for moving from a monolith to a microservices architecture. This is the strangler pattern. You can read up on this. But the only really point that I want to point out here is if you go down this route and decide to start creating these mini modules all over the place and you stop halfway, halfway is actually much worse than the start. Don't just get halfway and like create an even bigger technical debt than you've already got. So with great power, the great power of creating distributed systems, which is what you've done when you've created microservice architecture, there is a great deal of responsibility. Because the other thing that I like to remind people of is that refactoring when you've got two separate applications is not super easy. And if you start duplicating services all over the place, you've spread that stuff all over your infrastructure. So it's kind of, I don't know, be careful. Because in 5 years' time, we're going to be like, what the F was that? And why did we think that was a good idea? Because microservices are a choice. They're not an answer. They're not the solution. They are a potential solution, which is something we seem to forget a lot about in our industry. But they are our current solution. So this was the easy bit, focusing on coupling and cohesion. That's the most important bit. But you can create the most beautiful architecture diagram you want. Once you involve these things, like people, processes, it all goes to poop places, not good. So you have to create the environment that supports continuous delivery and the architectural discipline, because a process or structure change doesn't really have lasting change. People don't follow rules. They're basically, even technologists, even as very logical, rational people, are like a very complex organism. And some days we wake up and we're happy, and some days we wake up and we're not happy. And sometimes we hate other teams, and sometimes we don't mind them. So the real elephant in the room is actually Conway's Law. I'm assuming most people have heard about this at some point, but even though we talk about it all the time now, I don't see many people really thinking about what does that mean to them. Because legacy organizational structures will destroy your beautiful architecture every single time. They'll also make your best people leave. And this is a quote from Michael Nygaard's book, Release It. And Release It is a great book if you haven't already read it, which talks about, the real issues around releasing software and scaling software and how do you implement circuit breakers and all this good stuff. And even he says you probably should design your teams around how you want your architecture to look. Now, one way to do this is to think about platforms, products, and services you provide and how they will be delivered. Because even with team structures, again, it's all about coupling. Sorry, just about coupling. Because actually, when you start thinking about, well, how do I design my teams around the architecture I want, you come back to coupling again. So thinking about the life cycle of the platforms that you create, whether that's infrastructure platforms or experimentation platforms, some of the underlying infrastructure that you have in your organization, and the services that you create, and the products that you provide to end users, and throughout the whole architecture and the different services that you create in there, whether they're monoliths or microservices or whatever event-driven crazy model you come up with, it's all about the life cycle of how the customers use them, the life cycle of deployment. Just think about business capabilities. It's not whether you're a DBA or whether you're a .NET developer, or whether you're a JavaScript developer, customers don't care about that. Boarding and reservations are two separate capabilities. They may be supported by the same infrastructure platforms, but they're likely to be supported by different services and different databases. And you also have to structure the teams around that, because you will always have some level of coupling. You simply cannot avoid it. And the last thing is ownership is also really, really important. Projects die. I'd like to call this platform, services, and products, not projects. But projects die, and when things die, they get entropy. And when you get entropy, you get debt. When you get debt, things are slow and expensive. And let's not forget all the other stuff that goes on in your organization. Political fiefdoms and silos, and basically every time I've gone into a large enterprise and started implementing continuous delivery, let's say about 80% of the time, I've ended up in front of HR. Why do I end up in front of HR? It's not because I'm getting fired. It's because people now have new roles and new responsibilities, and they need to be measured in new ways. Otherwise, they will subvert any beautiful picture we draw. So think about all of this other stuff as well. So remember these two things. Conway's Law is the law. And when people talk to me and say, I'm adopting continuous delivery, and they start talking about cloud technologies and containers and infrastructure and DevOps and all this fun stuff, and I'm just stood there shaking my head because I'm like, what are you talking about? Because the only thing I need to know about your technology is how much technical debt you have, and where is it in relation to the capabilities that you want to build. And that isn't questions I ask business people. That's the questions I ask the developers. Because what people and process issues you have and the maturity of your organization to deal with them is really whether you're going to be successful in implementing any of this stuff. Because there is no silver bullet. There is no easy way to do continuous delivery retroactively. You have to focus on creating loosely coupled applications and create teams and communication structures that support that. And that literally impacts every part of your organization. So you probably shouldn't decide to do continuous delivery everywhere all at once. Good luck with that. So focus on coupling cohesion. Remember that Conway's Law is the law. And finally, hope is not a design method. You have to be very intentional about this stuff. Don't get caught up in microservices. Don't get caught up in continuous delivery. Don't get caught up in containers. None of that shit's going to solve your problems. Intentional design, thinking about how things are coupled together, thinking about where you need cohesion and where you can get away with not having it. And then you might be successful at implementing continuous delivery. Thank you.